I built a Devops Capstone project, and in this video I'm going to explain that so that you can get an idea of how can you build your DevOps project too, which can give you a head start. So without wasting any time, let's directly get into the video. Okay, so we are on our computer screen right now. So let me just first quickly give you an overview of the project. First of all, we have created all the services like Kubernetes cluster, Azure Blob Storage on cloud with the help of Terraform. Then we have pushed our code to GitHub, and that code is being automatically deployed by GitHub Actions. First of all, GitHub Actions is uploading all our Docker images, building all our Docker images and uploading it to Docker Hub. And then it is getting the context of Kubernetes cluster, which is running on cloud, and then applying all the YAML files to the cloud. If you're not able to understand this, don't worry. I have discussed everything line by line in depth and detail in this video. By the end of it, you'll be able to understand everything which I've done here. Also, if you don't know much about Docker and Kubernetes, I would refer you to watch few videos on it, try to practice it. If you want a tutorial on it, do comment down below, because without them, you may not be able to understand this lecture, as I have deployed this whole project on Kubernetes only. So first of all, for building a DevOps project, you can go to GitHub and pick up any open source repository. Feel free to pick any of my project and just clone it and try to deploy it using all the tools, all the best practices which you have learned, like uh, setting up services on cloud with Terraform, applying Kubernetes YAML files to Kubernetes cluster, containerizing your applications, etc. I've cloned this project from Rishabh on Cloud, so shout out to him. This is a simple QR code project where you will just paste your URL and it will generate a QR code for you. Here I've made a page where you can just simply type your URL, and then it will send a request to your Next.js server first. And then Next.js server will send the request to your backend, which is written in Python and Fast API. Why have I done this? I'll soon tell you after explaining the Kubernetes YAML file. That that time you'll understand it better. And then this API is the backend where I have set up Prometheus and Loki. As you can see here, you have to, or here also, put this type of URL according to your service name inside Kubernetes. I'll discuss it later. And on slash generate QR code path, the image is coming. It is uploading the image to the Azure Blob storage, where you can basically store any file, videos, etc. On slash metric, you can get data from the Prometheus. So this is the whole project. Now, how I have used a DevOps in it, how I have deployed it. So first of all, I have created a Docker file in Frontend, which is basically pulling the node image, then creating a directory, then copying the package.json file first, then running npm install, then copying rest of the file. Why I've done this? Because Docker uses a concept of layers while making the image. If I change something inside the file, npm install command will not run again as it has, because I have not changed package.json file. That's why I'm first copying package.json file and then rest of the files. Because if I copy all the files at once, then if I change really few things in my code again, npm install will start running, which is an expensive and time consuming process. That's why I've cached it, like Docker caches it, the layers. This you can consider is this as one layer, this as one layer. So concept of layer is there in Docker. Now for development, I have written run command npm run dev expose it on 3000. And for production, I have first built it, then npm start. In backend, I have also created a Docker file doing the same thing, copying requirement of txt, then installing dependencies, copying, exposing, and then finally running the app. Also, I've set up Docker Compose file here so that you don't have to open multiple tabs inside terminal and type different commands for running different containers. With just Docker Compose up, you can run all of them. So I have written here first build backend, refer to its CNV file. This is the port which I want to expose. Backend depends on Prometheus server. I've also used Grafana. Grafana is basically used to visualize the metrics of your backend, and Prometheus gives us the metrics. It stores the metrics, and Loki helps us in log collection, and we can visualize log collection on Grafana server as well. And then I have built the front end. Its Docker file, which I'm referring, target is equal to production because this Docker compose file is the production and dev one is this for development purposes. And then I've mentioned Prometheus, Grafana, on which ports they are running, which image to pull for them. Also mounted a volume for Prometheus where Prometheus can store its metrics so that metrics persist even after we close the connection, and we were unable to run the Docker because I have not started it on my PC. So Docker Compose's file is basically where you can mention all the things which you want, all the images, all which you want to build, and then run it at the same time instead of making separate Docker files, running them separately with different commands. So we have discussed the Docker part. Now let's move on to Terraform. In if someone don't know about Terraform, Terraform is basically used to create an infrastructure on cloud, which basically means all the services which you can create through GUI, you can, instead of creating those services through GUI, you can just write the code and create those services through the code, which is much more efficient, and you can use that code later in your other projects. So you don't have to set up every service again and again by clicking on different buttons on GUI, for example, again and again creating a resource for project where you are using the same old services. So I have first mentioned the Kubernetes cluster service, which I want to create on Azure in Kubernetes.tf file. In storage service, I have mentioned the Azure blob storage, which I want to use. And this is the resource group, which I want to create. Resource group is basically used to organize things in uh, Microsoft Azure. You can create different groups in which you can store different services. It is basically used for organization of different services. Provider I have mentioned Azure, and then in outputs.tf I have made the output of container name, which will basically tell us the container name of the storage, and it will give us the storage account name in the output, and this will give us the Kubernetes configuration file which we might need for logging in inside the Kubernetes. So we are outputting all those. We can store it in our local uh, we can store those in locally. For example, I've stored kubeconfig file here, which can basically help you interact with the cluster, get the context of it. And in the main.tf, I've basically configured the Azure provider. And now for creating those services, you have to just write Terraform up at first Terraform plan and then Terraform apply, and those services will be created on your cloud within few seconds. So it's really amazing. You can just create services with the help of code instead of going to the GUI again and again separately for different projects, which can take a lot of time. Now let's move on to the Kubernetes part. First of all, I have created a backend deployment here, which basically refers to my image on backend, which I have uploaded on Docker Hub. It gets that image. It has some key value pairs, which is the Azure storage connection string, which it needs to store the QR code in Azure Blob Storage. And then we have created a backend service, which is of type cluster IP. Cluster IP service type basically means you can interact with those services inside Kubernetes cluster only, not from outside. So this is the backend deployment file where I'm pulling the image and running the container on port 8000. Then this is the backend service with which I have to interact to get access to my backend inside Kubernetes cluster. It is also running on port 8000 and its target port is 8000, which refers to the port of the container target port. And we have the container port is 8000. That's why we have to mention 8000 here also. And this file we'll discuss in the end. First, this is the front end deployment, like the backend one, it is pulling the image from Docker Hub, and then front end service is running. So front end is also of type cluster IP, but how I am able to access front end? Because I have used a service called ingress, which basically, whenever I go to the domain of the Kubernetes, basically routes the request on whichever path I'm standing to its service, and then I'm able to access that service. Obviously, for example, if I go to the domain on slash path, which is the home, which is basically the home page, I'll go to the front end service. It will route my request to the front end service, and I'll be able to see the front end. Now, for making the ingress work, we need nginx, which is like a reverse proxy, which provides us an external IP address, which makes the Kubernetes service available externally. And whenever we go to that IP, the nginx will route the request according to our ingress configuration, which we have written. So for ingress to work, we need a reverse proxy load balancer service like nginx. And like the front end and back end deployment, this is Loki deployment, Loki service, Prometheus, Prometheus service. This is secrets, which I have used as Azure storage container string to connect with Azure, just like env variables, which I'm using in which I'm using in backend. And this is the config map which you require for some Prometheus configurations. So this was all about K8's Kubernetes, how I have used different YAML files to deploy Kubernetes. Now, how all of this is working, let me just explain. So first of all, why I have sent the request to first Next.js server and then Next.js server sending request to backend. I've done this because I can access backend inside Kubernetes cluster, not outside it. It is of type cluster IP as you saw in YAML file. I can't access the backend outside the Kubernetes. When I send requests to the backend on frontend, if I directly send requests to backend on frontend, then the request will go publicly to some service. It will not route exactly to the Kubernetes cluster. And even if I put the IP address of Kubernetes cluster, still I'll not be able to access backend service from outside, as cluster IP services can be accessed inside Kubernetes cluster only. That's why I first sent the request to Next.js server, which is running inside Kubernetes cluster, and then that Next.js server is sending request to the backend. So as you can see here, you can't really send request to backend service directly, as it is a cluster IP type of service here. So you can't send it the request inside the Kubernetes cluster to a cluster IP type service from outside. Either you can send it through the front end cluster IP which is running. That's why I first send the request to the front end server, Next.js server, and then the Next.js server sent the request to the backend service. Or you can create a route inside ingress for the backend, which means you are exposing your backend to all the world. So both the ways are correct. You can go with any way. If you expose directly with the help of ingress and load balancer, then you can directly make a call to backend from front end of your website. Otherwise, you have to go to the load first request to this front end, and then this can request backend service, or you can create a reverse proxy inside the front end with the front end files. So that's why I was sending the request from frontend to the Next.js server first, so that I can reach here frontend cluster IP, and then this was sending a request to backend service. And Kubernetes has a service named kubedns, which basically resolves this URL into the IP of the backend service which is running. That's why this URL in this format, which is first the name of the service, then namespace, then .svc, .cluster, .local, and then the port on which your service is running. In my case, it was 8000. Likewise, you can set the URL of Loki Prometheus running. Okay, so I have started my Kubernetes service. As you can see here, inside workloads, all our services are deployed. These are going to start, the ones with the exclamation mark. And I can simply go to this IP address and the load balancer will redirect to me to the front end service. Now I can type anything and it will generate a QR code. And on going on slash Grafana, on going on slash G, I can access the Grafana service here. And as you can see here, Kube DNS services, which is running, which resolves the IP addresses inside the Kubernetes. Now let's discuss the last part of our project, which is the CI/CD pipeline. First of all, what is CI/CD pipeline? CI/CD pipeline basically helps you to automate the process of deployment whenever you make changes and push it to GitHub. I've used GitHub Actions for CI/CD pipeline. GitHub Actions will automatically deploy all those changes to the cloud. So what have had done in CI/CD? Whenever you will push an image, first of all, it will set up Azure CLI. I have provided the credentials of Azure. Then it will set up Docker, login into Docker Hub. I have provided its credential also in GitHub Secrets. And then it will build backend and push its image. Then it will build frontend and push its image. Then it will set up kubectl. Then it will deploy it to Kubernetes. It will apply YAML files and it will set up the kube config so that it can get the context of the Kubernetes which is running on cloud. Remember, we have outputted kube config file here from the output of the Terraform. So we are using that kube config file on GitHub so that it can get context of the Kubernetes services which is running on cloud and then apply YAML files to it. And then it does some cleanup task and it is finally deployed successfully to the cloud. And this is its code on push branch main. Whenever we push to branch main, these jobs will be run. First is build and deploy. It will run on Ubuntu. Check out code, then set up Docker, log into Docker, build and push image, then set up Azure CLI, then get the context of Kubernetes from kubeconfig, then deploy to Kubernetes, apply all the YAML files. So this was the overview of this project. Let me give you a quick revision and explain it through a diagram. First of all, we are creating the infrastructure on cloud with Terraform, which is basically creating different services like Azure Blob Storage, Kubernetes cluster. Then we are pushing that code to GitHub. GitHub Actions is running, which basically builds and push our images to Docker Hub. It applies YAML files. Cloud gets the image from the Docker Hub, or as all the images are mentioned inside the YAML files. In Kubernetes YAML files, first of all, we have created a backend deployment, which deploys our backend. Then we have created a backend service through which we can interact with that backend inside Kubernetes cluster. We have also created nginx service, which helps us to route the request to different URLs according to our ingress configuration, which helps us to basically interact with the services from outside world. On slash path will go to frontend service, or slash g will go to Grafana. And then we have deployed other monitoring services like Loki, Prometheus. We have also created Docker Compose file, so it's really easy to run and test it locally also. Also, one point to keep in mind, if you want to use this project, then whenever you are running locally, you have to use slash backend path here, because uh, on Docker Compose file, all the services written here will have the same network. So for backend's name is backend in Docker Compose file. So to send request to backend, we have to send request to slash backend and then its port number. That's why you have to write slash backend here to send the request to the backend services from inside the container. So that was the overview of my DevOps project. I have seen nowadays many people not deploying their application. They are afraid of deployment because they are afraid of bills. What if a huge amount of bill come? But you won't learn unless you deploy your applications to cloud. The only way to learn efficiently and remember everything which you have learned is to just actually build the product. And nowadays most of the cloud provider provides free credit, so don't worry about bill. You'll get $200 to $300 free whenever you will start, so you have ample amount of credits to experiment with. So that was it for this video. If you found this video helpful, don't forget to like, subscribe and share it with your friends. Do comment down which type of videos do you want in the future. I'll see you guys in the next one.